we tend to think of control as a good thing. It feels like stability, clear rules, centralized decisions, and strict oversight all promise order, predictability, and safety. In complex systems, whether it's a company, a government, or even an ecosystem, our intuition tells us that tighter control leads to better outcomes. And at first, it seems to work. The system becomes more consistent. Errors seem to go down. From the outside, everything looks stable and well managed. But over time, this stability proves to be an illusion. Highly controlled systems often become incredibly fragile. They perform perfectly under normal, expected conditions, but they fail suddenly and catastrophically when circumstances change. What looks like strength is actually a hidden, profound weakness. So, why does this happen? To understand why control creates fragility, we need to look at how systems respond to uncertainty, variation, and stress. First, control tries to reduce uncertainty. Rules, procedures, and centralized authority are all designed to limit the range of acceptable behaviors. This makes decisions predictable and outcomes feel manageable. This reduction in uncertainty is comforting. It creates the impression that risks are contained and understood. But here's the catch: uncertainty isn't eliminated. It's just pushed out of sight. The natural, messy variations of the real world don't just disappear because you made a rule against them. They accumulate beneath the surface, unseen, like pressure building along a fault line. This leads to the next point. Fragility emerges when adaptation is suppressed. What makes a system resilient? The ability to adapt. Resilient systems adjust their behavior when conditions change. They rely on local information, on-the-ground judgment, and flexibility to respond to unexpected events. Control actively suppresses this adaptability. When all decisions are made at the top and behavior is tightly constrained, the people on the front lines lose their ability to respond effectively. They are forced to follow rules instead of reacting to the actual context. They wait for instructions instead of acting on their own valuable insight. As a result, the system becomes less and less capable of handling anything new. Fragility emerges not because people are failing, but because the system has had its ability to adapt surgically removed. Furthermore, control shifts responsibility upward. In a highly controlled system, decisions are made by a few people at higher levels. Authority becomes concentrated. Lower-level participants are simply expected to comply, not to think. This shift removes accountability from the edges of the system, from the very places where the most current and relevant information exists. When people aren't allowed to decide, they are not expected to understand the broader consequences of their actions. They just execute instructions without owning the outcomes. So, when something inevitably goes wrong, the system struggles to respond because responsibility has been completely abstracted away from the problem itself. This concentration of power also creates single points of failure. When one single authority, one process, or one computer system governs all behavior, its failure affects everything downstream. If that central control mechanism breaks, the entire system is compromised. Think about it. Decentralized systems distribute risk, but controlled systems concentrate it. The more you centralize control, the more fragile the entire system becomes. Control also relies heavily on standardization. Standard rules and procedures are meant to treat similar situations in the same way, which sounds great for efficiency and consistency. But the real world is messy. Situations are rarely identical. When you ignore context, decisions become misaligned with reality. Edge cases are handled poorly, and exceptions start to pile up. Eventually, people learn to work around the rigid rules instead of engaging with the system openly. Fragility grows as the gap between the standardized, idealized version of the world and lived reality widens. This brings us to another subtle danger. Control encourages compliance over understanding. In highly controlled systems, following the rules becomes more important than understanding why the rules exist in the first place. People are rewarded for adherence, not for insight. Over time, genuine understanding of the system deteriorates. Participants know what to do, but they have no idea why. So, when conditions change and the old rules no longer apply, they lack the critical reasoning skills needed to adapt. They just wait for a new set of rules instead of responding creatively. Compliance has replaced comprehension, and the system has lost its collective intelligence. One of the most insidious things about control is that it masks its own weaknesses. Controlled systems often perform beautifully under normal conditions. All the metrics look stable, the processes appear efficient, and everything seems fine. The weaknesses remain hidden because all the natural variability has been suppressed. But when stress finally hits an economic shock, a new competitor, a global pandemic, these weaknesses surface suddenly and dramatically. The failures seem to come out of nowhere, even though they were accumulating quietly for years. Control doesn't prevent failure, it just delays it, and in doing so, it often amplifies it. Control also distorts feedback. When behavior is tightly constrained, the feedback you get reflects compliance, not reality. Your metrics will show you whether people are following the rules, not whether the system is actually functioning well in its environment. This distortion creates a dangerous false confidence. Leaders believe the system is healthy because it appears so orderly and predictable. Meanwhile, adaptability and resilience are quietly eroding. By the time the feedback finally reflects real, deep problems, it's often too late for any easy corrective action. And what about learning? Learning requires experimentation. It depends on variation, making mistakes, and adjusting course. Controlled systems are designed to minimize all three of these things. When behavior is tightly regulated, opportunities for learning vanish. Mistakes are hidden rather than examined. Deviations are corrected immediately, rather than being understood. The system effectively stops learning about its environment and itself. Fragility increases as this institutional knowledge stagnates. All of this creates an illusion of mastery, which leads to overconfidence. Because behavior is predictable and outcomes appear stable, leaders become certain that the system is totally under their control. This confidence discourages questioning. Warnings are dismissed as noise. Anomalies are ignored. The system appears too well managed to possibly fail. Overconfidence grows at the exact same time that fragility is increasing. And then, stress reveals the truth. Unexpected events, rapid change, or external shocks test the system's ability to adapt. And this is where controlled systems crumble. The old rules no longer apply. Centralized decision-making becomes a bottleneck. Local actors, who see what's happening, lack the authority to respond. Failures begin to cascade through the system. What appeared stable just moments before breaks suddenly and completely. It's important to see that control and optimization often reinforce each other. Optimized systems favor consistency, and control enforces it. Automation then encodes it. Together, they create highly efficient but incredibly brittle structures. Judgment, discretion, and flexibility are systematically removed in the name of performance. The system excels in a predictable environment, but shatters in any other. So, what's the alternative? Resilience. And resilience requires distributed control. It means allowing decisions to be made where the information actually exists. It means tolerating some variation and trusting people's judgment within established boundaries. Now, this distribution might appear inefficient. It can introduce some inconsistency and uncertainty. However, it's what enables rapid, effective adaptation. Resilience isn't about eliminating uncertainty. It's about building the capacity to respond to it. This doesn't mean all control is harmful. Of course not. Boundaries, constraints, and shared standards are necessary. The problem arises when control becomes total. Effective systems are smart enough to distinguish between the areas that truly require consistency and the areas that demand flexibility. This selective control preserves stability without killing adaptability. Designing for resilience over control requires making trade-offs. It means accepting a little inefficiency for the sake of robustness. It means allowing for discretion and tolerating some variation. These choices might reduce short-term performance metrics, but they dramatically increase long-term survival. Fragility emerges when we value control more than we value resilience. In the end, control feels reassuring because it promises certainty in an uncertain world. But complex systems can never be fully controlled. Attempts to do so often increase our risk rather than reduce it. Accepting the limits of control requires humility. It means recognizing that uncertainty cannot be eliminated, only managed. So, to conclude, control creates the appearance of stability by suppressing variation and concentrating authority. But in doing so, it removes adaptability, learning, and local judgment. Fragility accumulates quietly, hidden beneath a surface of order. And when conditions finally change, these controlled systems fail abruptly. This isn't because the control was poorly executed. It's because the very nature of total control changes how a system responds to the world. Truly stable systems are not the ones with the most control. They are the ones with the greatest capacity to adapt. Thanks so much for watching. If this idea resonated with you, Consider subscribing for more content on systems, thinking, and resilience. See you in the next one.